Let's go ahead and try a question on firm supply. So as always, I'll explain how I'm parsing the information as I read through it and any decisions I'm making along the way in terms of how to go out solving the problem. All right, let's jump in here. A firm has two different factories that it can use to produce notebook computers, factory A and B. Total cost, marginal cost functions for these two factories are given by all of this here. Right, so that's nice, we've got our marginal costs already, although we could have gotten those anyway by taking the derivatives of those cost functions. Okay, so NA's number of notebooks produced at factory A, NB number of notebooks produced at factory B. Okay. Part A here. If the firm is going to produce a total of N notebooks, what fraction of these notebooks should produce at factory A, what fraction should produce at factory B in order to minimize costs? You can assume that the firm has to pay any fixed costs associated with the factory, even if it produces 0 notebooks at that factory. Okay, so for part A here, right, we've got these two different factories. What the firm's going to want to do is have marginal costs be the same at those two different factories, right? Because if they weren't, then you could shift output from the higher marginal cost factory to the lower one and save a little money. All right? Okay, so we were already given our marginal cost functions. So let's just plug in here. So 20 NA is going to be equal to 40 NB, all right? And so NA is just going to be equal to 2 NB in this case. Right? We want these things in terms of total N. So our total N is NA plus NB. All right? And so I can plug this in for NA here. So I've got total N, it's going to be 2 NB plus NB, right? Which is just 3 NB. Right? All right, so what I really want to solve for here is NB, not N. So I'm just going to move that 3 to the other side to get that NB is going to be equal to 1 over 3N. And that means that NA, which is 2 times that, is going to be 2 over 3N. All right, so there is our final answer for part A. Okay, so going on to part B, derive an expression, Cn, giving the total cost of producing N notebooks, assuming the firm divides output between the factories in the optimal way. All right, so we're going to use that part A answer to come up with our cost function here. All right, so let's tackle part B. Okay. So costs of producing N notebooks, those are going to be the cost at factory A of producing what we produce there. And we just found out that's going to be 2/3 N. Plus the cost at factory B of producing 1/3 N there. Okay. All right, so now we can just go ahead and plug in our cost functions that were given to us at the top of the problem. So Cn is going to be equal to, all right, now Ca is 1,000 plus 10 NA squared, so that's going to be 2 over 3N squared. And now CB, we've got 2,000 plus 20 NB squared, so that's going to be 1 over 3N, all of that squared. All right, so I got 1,000 plus 2,000, it's going to give me 3,000. I've got 4 over 9 times 10, so that's going to be a 40 over 9 N squared. And then I've got a 20 over 9 from this term. Okay, so if I combine those things together, 40 plus 20 is going to be 60 over 9 N squared. And I can write that a little bit more simply by dividing the top and bottom by 3 here to get 3,000 plus 20 thirds N squared. All right, there's my cost function for part B. Now let's see what we have to tackle in part C. Find the firm's supply function, NP, assuming the industry for notebook computers is perfectly competitive. Okay. All right, so what is a firm going to do in a perfectly competitive industry? Right? They're going to go to where price is equal to marginal cost. All right? So in this case, right, everything's a function of n here. So that's going to be price is equal to the derivative costs with respect to n. Okay. So I look up at my cost function. First term doesn't have any n's in it, right? Second term, I'm going to bring down my exponent. It's going to give me 40 over 3. Lower my exponent. That's just going to give me n to the first. Okay. But the question wanted n as a function of p, not price as a function of n. So all I have to do now is just rearrange this thing, right, to get 33 over 40 on the other side, and that is times p. So that is my final supply function for the firm, right? N is a function of price. Okay. So now let's look at part D here. How would your answer to parts A and B change if instead of the total cost and marginal cost functions above, you were told that the factory's total cost functions were 1,000 plus 10 NA plus, and CB was 2,000 plus 20 NB. All right. So how is that going to change things? Well, what's different here, if I go back to my original cost functions, is instead of 10 NA squared and 20 NB squared, it was just 10 NA and 20 NB. So that is going to change what my marginal costs look like. So my marginal costs for A are now going to be the derivative of this cost function with respect to NA. So that 10 NA is just going to leave me with 10 when I take the derivative. Right? My marginal costs for B are now just going to be 20 because of that 20 NB term. All right, so this is a fundamentally different situation now because we've got constant marginal costs at our two factories. No matter how much we're producing, it's always going to be cheaper to use factory A than it is factory B, right? And so now our NA is just going to be our total number of N. Our NB is going to be 0. And we're going to explain why. We're just going to say because MCA is always smaller than MCB. Okay. So we're going to produce everything at factory A, right? And so our costs of producing an amount N are going to be our costs of producing N at factory A plus our costs of producing nothing at factory B. And I still need to factor that in because we still have those fixed costs of factory B. Remember, earlier in the problem, it told us we still have to pay those. All right, so now we've got our new cost functions, we need to use those. So 1,000 plus 10 times N plus 2,000, right, plus 20 times 0. Right? And so our final cost function is just going to be 3,000 plus 10N. Right? And so that is how things are going to change in terms of both how we split up our output and what that means for our cost function. All right, so we're done.